Today we'll be solving more systems of equations in word problem format. So here we're going to have to sometimes create the equation while we're doing some work. I'm going to do one and 2 with you. You'll be on your own for number 3. So for number 1, a rectangle's length is 5 less than 6 times its width. Write one function that models the perimeter of the rectangle and one that models its area. Graph the function on the coordinate plane below. Determine the measurement for the width of the rectangle that will make the perimeter and area of the rectangle equivalent. All right, so we have width is going to be our x and length is going to be our y. So we know that the length, let's start by just drawing out a little picture here. Might make it easier. We know that the length is 5 less than 6 times the width. So the width is going to be x and the length is 5 less than 6 times the width. So 5 less than 6 times 6x minus 5. So now we have 1 for the perimeter and 1 for the area. So I lied. Y is not going to be the length. Y is going to be our answers for perimeter and area. All right, so we have for perimeter, y would be 2 times x plus 2 times 6x minus 5. That's our perimeter formula. Then for our area, we're going to have y equals x times 6x minus 5, since it's just length times width. So now we can go ahead and rewrite both those equations or simplify them a little bit more so it's easier to graph them. So we have y equals 2x plus 12x minus 10 if I distribute the 2, which is equal to 14x minus 10. And then in our second equation, we could leave it the way it is. I like to see my x squared, so y equals 6x squared minus 5x. All right, so in both these cases, since my scales are not really the same, I'm going to just pull them up on my graph to make it easier. So we have for perimeter 14x minus 10. And then for area, 6x squared minus 5x. Then we can pull up our tables and start to graph. So in this case, again, we're only using realistic dimensions, so we only want positive values. So starting with that first graph, I can't even graph the 0, negative 10, so I'm going to ignore that and go right to 1, 4. So from 1, 4, I have 1, and then about 4 would be like here. And then 2, 18, a little bit above the 15. 3, 32, a little bit above the 30. 4, 46, a little bit above 45. 5, 60, and 6, 74. Draw my line through that. Arrow continuing in the greater direction and label it with the equation y equals 14x minus 10. Or perimeter. Okay, either would work as your label. All right, then for our second equation, we have 0, 0, so we can graph that point. Then 1, 1, even under the 4. Then 2, 14. 3, 39. And 4, 76. Okay, so that looks like this. And that's going to be our area formula. So from there, we really didn't see an actual point of intersection that is a whole number, nor do you see it on the graph. But it kind of looks like it's going to intersect in between 2 and 3. If we try to narrow down our table, let's see if we see it that way. If we go to table setting and change it to 0.5, let's see if we get anything that comes up. Anything the same, anything the same. It looked like it was between 2 and 3. Oh, look at that. 2.5 is exactly 25. So our graph's a little bit off. It should have intersected exactly right here at 2.5 and 25. So our solution is that whenever the width is 2.5, the perimeter and area would both be 25. Okay, so a width of gives a perimeter, gives an equivalent perimeter and area of 25. Okay, so use your calculator to help you find those solutions if you don't see it exactly on your graph. All right, number 2. Lily opens a bank account with $1 and her account doubles monthly as represented by the function y is equal to 2 to the x. Jaden also opens an account with $40 and adds $27 each month. Model each account with a graph and determine how many months it will take for them to have equivalent amounts saved. So again, we have Lily. This thing is driving me crazy. And that's y is equal to 2 to the x. And then we have Jaden, and his equation isn't given, but we can easily find it because it's a linear function. He starts with 40 and adds 27 each month, so that's y equals 27x plus 40. All right, so we can graph both those equations using our calculator. We go to y equals, clear what's there, and we do 2 to the x for the first one, and then 27x plus 40 for the second one. And pull up our tables. I'm going to change my table setting back to changing by ones. All right, so we start at 0. So for Lily, 0, 1 is going to be our first point. Then we have 0, 1, 2. Should be even pretty low. I mean, it's kind of hard to estimate there. And then 2, 4. So it's growing very slowly. 3, 8, not even at the halfway mark of 15 yet. These points should probably be a little bit lower. Then 4, 16. 532, 664. Now we're growing more quickly. 7, 128. 8, 256. Be about there, and we can draw our line with an arrow on the end and label that y equals 2 to the x or Lily. Okay, then going to Jaden's, our y-intercept is 40. This is going to be 45, so we're going to be a little bit lower than that. And then 167. Now remember, this is a linear function, so when I'm graphing it, you should see a pattern. It should be linear. All right, so then we have 294. So make it look like it's going up and over the same amount each time. 3, 121. 4, 148. 5, 175. 6, 202. 7, 229. And then 8, 256 again. So then we can draw a straight line through those points with an arrow at the end. Label that one Jaden, or y equals 27x plus 40. All right, so our point of intersection right there is the 8, 256. so we can answer the question with, after 8 months, they will both have $256 saved. All right, so you are on your own with number 3. Go ahead through that, graph it, answer the questions on GoFormative, and then you can start tonight's homework.